Hello everybody, here's a quick tutorial on how to start breadboarding mission turn signal. So I just want to let you know that there is a special holder for the integrated circuit called the IC socket, and it looks like this, okay? It basically is not a chip, rather it is a holder for the chip, and what I'm going to do is I'm going to plop that in to my breadboard, and then the thing to recognize is that you know the top of the socket holder with the little notch, okay? So this little kind of indent there at the very top, that's how we define the top of the device, okay? And so the way it looks is we've got 1, 2, 3, 4 for pins, and then on the bottom 5, 6, 7, 8 for pins. And so that, just to sketch, is this, okay? Sorry, 1, 2, 3, 4 down the left, 5, 6, 7, 8 back up the right, and then the notch at the top. So what you want to do is you want to take your 555 timer chip, which is this little puppy here, and you want to make sure that the notch at the top of your timer matches the notch for the socket, and then you just kind of pop it in there and gently press down. And there it is. So now with the notch at the top of the chip here, you know that you've got 1, 2, 3, 4 down the left, and then 5, 6, 7, 8 up the right. Okay, so let's have a look at the circuit diagram. We're going to be using the one indicated behind me, and there's a lot going on, and you just want to make sure that you get every single pin number totally correct. So I'm going to start with number 1. It looks to me like number 1 is pinned to ground. Okay, so that means I'm going to take my ground bus, that's my blue bus here, and I'm going to just jumper between the ground bus and pin 1, and remember that this entire row 10 is attached to pin 1. Alright, so that's going to look like this, and then into there. Sorry, this is a little tricky to do. I've got the camera very, very close to the breadboard, so I don't want to, so it might get a little bit wobbly. All right, so that would be pin 1 to ground, okay? And remember, the blue line here down the side is my ground bus. Okay, I'm also going to start on the other side with pin 8 going to positive VCC, so that would be over here. I'm going to take a jumper and go from pin 8 to the red bus on the other side, like that. Sorry about the wobble. So I've got red to pin 8 and then ground to pin 1. Okay, so let's see here on my circuit diagram. I've got number 2. That's my triggering voltage, which goes to the top of my capacitor. So what I'll do is I'll take my electrolytic capacitor with its long leg being positive and its short leg being negative, and I'm going to take pin 2 and I'm going to connect that to the top of the capacitor, and then you'll notice here the bottom of the capacitor goes to ground, also known as my blue bus. So I'm going to say the negative leg of the capacitor to ground, the positive leg of the capacitor to pin 2. So that would look like this. Positive and to pin 2, and then negative to ground. Now obviously there's a bunch of different ways you can do that, but I'll just say that that's one of them. Okay? Okay, now let's look carefully at pin 2. It looks like there's nothing else connected to pin 2 except pin 6. So pin 6, if you take a look there, my threshold voltage is also talking to pin 2. So let's grab a jumper and we'll go from 2 to 6. So basically we're going to have to kind of go, we could go over the chip or around the chip, but we're going to be going from this guy to this guy. That's 2 to 6. So I'm just going to use kind of a big wire there, but you can use whatever you like. So I've got my 2 here, and I'm going to go around the chip to 6 like that. Remember, the breadboarding doesn't need to be beautiful, but it does need to be functional, so that's 2 to 6. Okay, remember the reason why 2 to 6 talks to one another is because pin 2 is my threshold, excuse me, my triggering voltage, or my, and the reference there is 1/3 VCC on comparator 2. And then pin 6 is the threshold voltage, and that gets the 2/3 VCC into comparator 1. And basically both of those need to quote unquote talk to the top of the capacitor. Okay, my R2, excuse me, why don't I go to pin 3? Pin 3 is my output. So basically what I want for pin 3 is something that's going to go to an LED eventually. So I'm just going to take pin 3 and I'm going to send it elsewhere off on the board. Okay, so here I've got this gray wire going from 3 to down here, and then ultimately down here I'll be putting an LED to ground, so that because pin 3 provides my output signal. Don't forget your current limiting resistor. Okay, pin 4, it looks like, let's see, where does pin 4 go? Let's skip pin 4 for now. Pin 5, there's my little buffering capacitor. You don't need to really worry about this much. That value is going to be one of your tiny nanofarad ceramic capacitors. So we'll just say pin 5 to ground, like this, 5 to ground. Okay. And the key thing there is you recognize that we've got the ground bus on the other side as well for convenience. Generally speaking, we don't like to try to get components to go over the midline because that can get a little confusing. Okay, pin 6 we took care of. Pin 7, the pin 7, my discharge transistor control switch. So pin 7 is going to go to the top of R2, and the top of R2 is also, and the bottom of R2 is connected to the top of the capacitor. So in that scenario, I will take my pin 7, and I'm going to put a resistor in it, and then I'm going to go straight to pin 2. Okay, so that would be pin 7 is the second to the top on the right. Pin 2, I'm going to do exactly what I just said I'm not going to do, which is I'm going to go across the midline. There we go, 7 to 2. It's a little tricky. Like such. Make sure you get them seated really comfortably in the breadboard. Like such, and so on. Okay, so that's a resistor. Oop, that's 8 to 2. See, I'm going to be careful with that. That's 7 to 2 with one of my resistors. This resistor is definitely not necessarily the value for R2. I'm just using random resistors to demonstrate the breadboarding pin layout. Okay, so let me just make sure I've got 7 at the end of resistor to the top of the capacitor, which also happens to be pin 2. Okay, and then finally I have pin 8 going to positive, but I also have pin 8 going to R1 to the top of R2, which is also connected to pin 7. So basically I need another resistor that goes from the positive bus to pin 7. So I will do that like this. I could go directly from 8 to 7. I could go, there's a bunch of different ways I could do this, but that's the general idea. A resistor to positive, and then that would be R1, and then my positive is also connected to pin 8. Okay, so that's just one way that you can breadboard this thing. But the key thing here is to just make sure you get your connections in nice and snug, because you want to. That's probably going to be something that will end up being something to debug if your connections are not snug. Okay, and then finally for pin 3 to ground, we're going to put an LED in there. So just give me a moment while I reach back and grab an LED. So I would take, so the pin 3 is going to be the positive side of the LED. So that would be my long leg. And then the short leg of the LED goes to ground. But before I do that, remember I've got to provide a current limiting resistor so I don't fry this puppy. So there's my LED. Again, this is the output of pin 3. And then LED to ground will look like this. Okay. All right. Now, so this is just a little tutorial in breadboarding, and then there's lots of other stuff to pay attention to with respect to determining the values, okay? But in general, that's the overall idea. Thanks very much for watching.